Hi, I'm Leanpub from Leanpub, and in this episode of the Front Matter podcast, I'll be interviewing Soledad Galli. Based in Berlin, Soledad is a content creator, data scientist, instructor, and software developer with more than 10 years of experience in both academia and big business. You can follow her on Twitter, or whatever it's called now, at Soledad_Galli, and check out her website at trainindata.com. Soledad is the author of the Leanpub book, Feature Selection in Machine Learning with Python, over 20 methods to select the most predictive features and build simpler, faster, and more reliable machine learning models. In the book, Soledad uses Python open source libraries to show you how to implement various feature selection methods in a few lines of code and train faster, simpler, and more reliable machine learning models. In this interview, we're going to talk about her background and career, professional interests, her books, and at the end, we'll talk a little bit about her experience as a self-published author and content creator of courses and things like that. So thank you very much, Soledad, for taking some time out of your early morning to be on the Leanpub Front Matter podcast.
Thank you for inviting me. I'm really happy to be here.
Thanks. I always like to start these interviews by asking people for their origin story and the story of their career. And I know you've had an interesting path. So I was wondering if you could talk a little bit about where you grew up and how you found your way into a career in sort of data science and machine learning.
Yeah, sure. Actually, it's my career is sort of not on a line. It's kind of full of zigzags. I grew up in Argentina, Buenos Aires, and I studied biology there. I also did a PhD in Argentina. It was a great experience. And then I moved on to first Germany to do a postdoc, and then to London or to do another postdoc in science. And then eventually I decided that I didn't want to, after 14 years, I decided that I didn't want to be in academia anymore for various reasons. I wanted to try something different. So I was a bit stuck because I thought I don't really want to go into pharmaceutical. I don't really want to do experiments anymore. And I said, okay, the things that I really like is, creating hypotheses, analyzing data, statistics, a little bit of programming. So data science was really trendy. I met a lot of colleagues that switched from academia to data science. So I started researching, contacting them to see how I could make the switch. And I discovered that actually you can teach yourself data science through online courses and books. At the beginning, I thought it was impossible because, I studied like 5 years biology, 4 years PhD, and then someone comes and tells me, oh, with an online course, you can become a data scientist. I didn't believe that. But it turned out to be true. Like, I took one course, I learned a lot, then I took another course, and eventually I was doing interviews with companies, and I was seeing that I was doing okay until the first one hired me. And that was how I entered into data science first. Then once you're in, it was really easy to look for another company that I liked more. And when I was working as a data scientist, I actually noticed that, there is a little bit of a gap between what you learn in these online courses and what you actually need to be a data scientist. And back in the day, and I think today it is true as well to some degrees, and particularly in some fields, there wasn't so much information available online about best practices and how to approach a machine learning problem or a data science project. So I decided that I would try and bridge that gap by creating online courses that are not intermediate, that are not for beginners, they are intermediate. It's like the second step. And they gather best practices and tools that have been used in businesses and also described in data science competitions and at universities that were not easily accessible back then into courses that I think are easy to digest and like a source that you can actually go for and check every time that you need. So that's a little bit in a snapshot.
Yeah,
career.
That's really great. It's really interesting. I have a bit of a kind of what they sometimes call a portfolio career myself, where there's sort of radical kind of changes, or at least that's what they appear to be from the outside. And I'm actually interested in talking to you about sort of two types of transitions that you've done. One from academia to kind of the business world, and then that from sort of like from sort of cellular and molecular biology, if LinkedIn is telling me the correct PhD that you got, to data science. But before we do that, longtime listeners of the show will know that anytime someone brings up the fact that they lived in London for a while, I did too. I lived there for about 9 years. And I always like to ask, where did you live in London?
Soledad is the council. It's a little bit south of Canada Water. Sorry, that's the tube station. London Bridge. The next one is Canada Water. I was there.
Okay, great. Yeah, I lived in Balham for a while, sort of south of the river, and I lived, sort of north in Golders Green and stuff like that in various other neighborhoods. But it's always nice to sort of like, there's so many different Londons, the experience people can have. But what was that like for you, sort of moving from Buenos Aires to I think you went to the Max Planck Institute first in Germany, and then you went to London. Did you find moving to Europe to be kind of difficult or easy?
Well, my first experience coming to Göttingen, it's what I call a small town in Germany, was shock, like a complete shock. A little bit, a big part my fault. I was very naive. I mean, I just lived in Buenos Aires. Buenos Aires is huge. I mean, I think 30 to 40% of the Argentinian population is in Buenos Aires and Greater Buenos Aires. There is a lot going on culturally and also politically. I mean, it's amazing as a city if you are into big cities. And like ignorant me, I thought, okay, going to Europe, it has to be Buenos Aires or even bigger. And I landed in this Göttingen that is like 150,000 people. Nothing to do other than going to 5 restaurants. I was shocked. I didn't think that this was possible. So yeah, I was kind of, I felt that I didn't fit in. So I did 1.5 years there, and I kind of had to go back to Buenos Aires to breathe in and recover from this shock. I think I was too young and too much of a city person to adapt there. So I went back to Buenos Aires, recovered my energy, and then I said, okay, I'm going to try again, but this time it has to be a big city. So that's why I picked London, and that was a different story. So I felt a little bit more at home. I mean, it takes time until you actually feel at home, but eventually I managed. Culturally, it's different, I think. Like Argentina is more Latino, friendly, open society, spontaneous is what I like to say about Argentinians. I felt that Germany and Londoners or British people are the opposite of spontaneous. Like if you want to see a friend, you need to book them in advance, weeks. If you want to go to a concert, you need to book tickets in advance, like 1 year ahead. Like, so it took a little bit of adaptation. But yeah, I mean, overall, it was fun. I liked it. I really enjoyed it.
Oh, that's really great. Thanks for sharing that. It's funny. My personal experience is kind of the opposite of that. I came from like a town of 150,000 people in the middle of Canada and moved to London. Just the guy was like a fish in water. It was just fantastic. It was all of a sudden, there's all these opportunities and stuff like that. But I know exactly what you mean about the spontaneity. Canadians are probably somewhere in between. Yeah, no, definitely. It's sort of great place with a lot going on, but there's also a lot of planning when it comes to sort of interpersonal interactions. You eventually decided to make this switch from academia to the world of initially to the world of business. So you worked for a big insurance company, I believe, or two. And what was that like? I mean, what was it particularly about academia? I have a doctorate, and I left academia myself for various reasons. But what were your reasons for doing that? What was it about academia that you felt sort of maybe in a bit more detail wasn't sort of for you?
It's quite like in hindsight, there's quite a few things that I particularly enjoy about academia. One thing is that I find it's very slow. Like conference after conference, I felt I was talking about exactly the same, and like it was almost like embarrassed. Like I'm going again to this same conference to say again the same results that I showed last year plus 1 or 2. I mean, experiments take a long time to do in molecular biology, and then you have to repeat them to be sure. So, I mean, it's justified. It could be a little bit faster, but well, it wasn't the case. So that's one reason. The other reason is that I found like a very narrow career progression, like very few career progression opportunities. There is no space in universities. Money is limited. So like I tried to apply to a few grants for a year. I said, okay, if I don't manage to become like a principal investigator to lead my lab in a year, then that's it for me. And I didn't manage. So I applied to a couple of grants. I didn't get the money. And it was funny because at some point I was talking with the director of the department and he says, well, you need to kind of start your own separate line of investigations. But you cannot do that if you're working in a lab with someone. You're following that person's line of investigation. So he suggested that I should work for this person during the day and then during the night, my own line of investigation to kind of show the world that I can actually think. And I was like, okay, this is too much. I don't really think I need to show anyone that I can think. If they don't see it, bye-bye. So yes, it was frustration mostly.
Yeah, no, definitely. I mean, I think a lot of people out there who've gotten to the PhD level and then done postdocs and stuff like that have similar experiences. And just one last sort of question about that, sort of personal question. I think you mentioned that sort of the pharmaceutical industry wasn't for you, although that might be the sort of normal career path. I've got friends who've done PhDs like yours who ended up sort of in the pharmaceutical industry. Was there something about the industry that you just didn't find attractive?
The way I saw it working for my pharmaceutical is like either I have to do documentation for drugs, which is extremely boring. I have colleagues doing that, and it's like, I don't know how they survive. Or you need to do experiments manually. And that is the one thing that I didn't want to do anymore. Like I want to think, I want to analyze data, I want to draw conclusions, but I don't really want to do the experiments myself. Like I had enough of that after 14 years. So, I mean, those two things I didn't like. And then, I don't know, like maybe it's just me, but I think that, the main driver of pharmaceuticals is profit, not really people's health. And I cannot engage with that. So overall, I don't trust them.
I think you're not really alone in that. If you've ever looked at the balance sheet of a pharmaceutical company, there's way more zeros than there probably ought to be, at least from a sort of certain perspective. And so you like working with data and you like thinking, and you also like learning, and eventually you maybe you didn't know it at the beginning, but you learned that you love teaching. And I just know this from some podcasts that I've listened to that you've done in the past, just while I was preparing for this interview. And so I'm really curious about so there you were, you wanted to get into data science. What was the sort of first online course that you took?
I started with the data science specialization on Coursera from, I think it's Johns Hopkins University in R. It's kind of overview of data science and the different things that you need. First, the tool set, what tools are you going to use? Then introduction to R, like more programming experience was almost zero. I did a little bit of MATLAB, but mostly copy and paste and try to decipher what other people did more than me actually doing it. So actually, I had to start from zero, like loops and if-else and all that kind of thing. And they were teaching that in one of the modules, and then a bit of statistics. That's the part that I was strong at. So, I felt that at least there was some boxes that I ticked. And then how to approach a project and stuff. Then someone recommended on LinkedIn a course on EDX. I took a step back. It was a little bit more basic and took like a project-based approach. Like we have this project, how do we go about it? And then they teach you random forest. We have this other project, how do we go about it? And then they teach you something else. It was really cool. I think they took it out from the catalog. That's a shame though. So, but yeah, those were my first two courses. Then I had to learn a little bit of Python. So I took another course also from Coursera on Python. And then eventually I already was working on a company by then. I took the one from Andrew on Coursera, which is kind of the machine learning course that I think almost everybody has done. Those were the first ones, yeah.
Well, that's really great to hear about, specifically about that Johns Hopkins course on Coursera. We're very familiar with that. Some of our best-selling authors, Roger Peng and Jeff Leake, were part of that course.
Yeah.
And they made Leanpub books to sort of go along with the course.
Yeah, exactly. That's how I got to know Leanpub. Like I thought it was like a cool idea. Like they were creating additional resources for the course, or almost independent resources, but they linked in the course, and I was like, wow, look at this Leanpub. This is an amazing resource for people to publish books, and then they have this price model that you can change the price, and this is good because people all around the world, they don't have the same disposable income, so I find it like super cool.
Yeah, that's exactly one of the things that attracted them to Leanpub, which is just so, and we were so glad to have them, and all of their hundreds of thousands of students, many of whom got the books for free, which is great, and sort of fostering this sort of community of people around the world learning about this really hot career kind of area. And so one thing I know, I'm not going to, you've talked about this in other podcasts that I've mentioned, and we can maybe link to them into description or something like that. But one of the really, so when sort of someone has the ability to deal with data that you developed and that you can actually kind of apply that to almost anything. And one of the things that you applied it to was insurance fraud.
Yes. Like how I did it is the question.
Yeah, basically, yeah. Like sort of what kind of fraud, I mean, I'm sure there's probably more than one, but if you can think of a sort of interesting type of insurance fraud that you were assigned to kind of look into and how you would tackle that from a kind of data science perspective.
Yeah, so I was working on motor insurance. So the model was for motor insurance fraud. And that basically covers a wide spectrum of things. The most important one is when people stage fraud. This is something that I didn't know that it existed until I entered into the insurance. So like people stage accidents. Wow. So basically they go into a roundabout or they are on a road and then they are driving, and then they brake brutally. So the one at the back crashes into, and almost always the one at the back is to blame. So it's very hard, like for an insurer not to cover that insurance. And then they go and they claim that they have tissue damage, which doesn't appear on any medical record. It's just the doctor's certificate. So it's very hard to dispute. So yeah, it was an interesting learning. This is some kind of thing. And at the back of that, an anecdote, like that's why some people that drive all the time, they're putting cameras on the top of the glass so that they can actually be prepared to anticipate people that actually stage fraud. So that was crazy. Anyhow, this aside, the approach is I would say more or less the same, but any approach is you have a data set with variables about the characteristics of the claims, and you enrich with data sources from other places. Then you have a label with a few claims that you managed to find out that they are fraudulent, and then feature engineering, feature selection, you create a model, which is for classification almost always going to be XGBoost, and voila.
Yeah, no, that's actually great. You give me the great podcast guest gift of a segue, so we can talk about your book, which is about one of your books, which is about feature selection and what that actually is. And so this very practical example. So let me just kind of make up a scenario. So there's an insurance company. It does motor insurance, and it's looking out for fraudulent claims. And so the data might be like, you might get a data set that has like time of day, speed the car was going, strength of the collision or something like that, and this sort of history, credit history of the people involved, stuff like that. So if you've got all this data, most people would probably envision a spreadsheet or something like that. What's a feature in that data? How do you what is that when you sort of pick that out of the variables in the data set?
Yes, well, the features are pretty much the ones that you mentioned. Like if you have a car, you probably have the model, the make, the color, you have the age of the car, you probably also have the age of the person that was driving the car and some personal details about the person. Some you can use, some you cannot use. It's slightly regulated. So each one of those could be a feature or a variable. If you have the date, you probably don't use that as such, but you can extract information, like, for example, the day of the month, the year, if it was in the morning, in the afternoon, things like that. All of those are features. Some of them are going to be predictive of whatever you want to predict, in this case, fraud, and some of them are going to be irrelevant, and some of them you cannot use because of the regulation. So then you need to select. So the first ones, following regulations, you have no choice. You basically eliminate all of that you cannot use. And for the rest, you can use machine learning algorithms to select the ones that are more predictive. And one of the reasons that you want to select is because particularly fraud models are going to be used with people. Like a fraud model almost always sends a flag, and then when something is flagged as potentially fraudulent, it's going to be investigated by people because the amount of false positives is really high. So I don't think, also, at least the fraud models that I work with, they don't make automatic decisions. It's just flags things that potentially fraudulent, and then they go and they are analyzed by people, and then the people need to be able to make sense of why a model said, okay, this is fraudulent. So you cannot have a model with 1,000 variables because you overwhelm people. And also most of the variables are going to be correlated. So that's one of the reasons why we select features. You make the models simpler and easier to use. And for models that are going to be deployed, also, the easier, the better. You expose yourself less to risk if you have less variables in production. And it's also easier for the developers, it's faster, so less is more in various aspects.
Yeah, no, that's great. That's one thing you talk about quite a bit in your book and elsewhere, is that, sort of keeping the model kind of as simple as one can is important for a number of reasons, one of which is sort of the performance of the sort of computing tasks that you're doing and things like that. But another one is interpretability, and, data visualization are a lot easier to get across to sort of like the whoever the user is on the other end of what you're making, if there's sort of fewer and sort of the most meaningful features that you can sort of pick out. And one thing that I'm really curious about that so just sort of to get a sense of this, sort of like I think you've written about the context and the story is just as important as the data. And you get that by looking at the data, right? So you might try out various sort of machine learning algorithms on various features that you've picked out, and you might discover to your surprise that, say, the color of the car somehow actually sort of corresponds to a higher rate of like true positives in flagging potential fraud. Is that how it works? Like you go into it without really knowing what you're going to find in the end, and you sort of use these techniques to find those patterns in the data?
Yes, you can certainly use the techniques to find patterns in the data. I think that in insurance and finance companies, you almost never, or at least I didn't work alone. You always work with someone that understands the topic well. So I always work with fraud investigators. Like I provide the technical knowledge if you want, and they provide the fraud knowledge. So like we were creating variables sort of together. Like they gave me a data set and they think, we think this is all the data that we have. And from here, we know that all of these things are normally found in fraudulent applications. So it's a bit of a combination. Like they tell me what normally comes together with fraudulent applications, and then I try to extract that information from the data. And then we sometimes also find surprises, like this variable that they didn't know actually is a good indicator, for example. That can also come from the machine if you want. It's a bit of both.
Yeah, no, it's just super fascinating work, and like as you say, there's sort of like lots of thinking that has to go into sort of handling this data, and I just love the idea of like it can be anything, right? It can be insurance card, it could be insurance motor fraud, it could be like credit card fraud, or it could be nothing crime related at all. But take these techniques and look for I don't know, protein folding patterns or something like that, or it can be anything, which is one of the things that makes machine learning and data science so fascinating. One thing I wanted to, since you're an expert in the area, one thing I wanted to ask you about is something people will read about in the news from time to time, is where it goes wrong. So for example, I think there was, I don't have the name at the top of my mind, but I think there was a post office related company in the UK that actually like prosecuted and like got involved in prosecuting, actually like convicting or at least firing people and sort of, for theft of parcels and things like that. And all that the people who were doing the persecuting were using was sort of output from some data model that they didn't interpret or analyze. And it turned out that a lot of these people sort of ended up fired or charged with crimes that they actually like weren't guilty of at all. And what was happening was on the user side of things, they were just relying on the output from the black box, and they didn't look into it and didn't care. How is it that people can, on your side of things, can help people who are maybe using these tools understand that there's always context and story to it, and that there's danger in sort of just accepting what it says at face value?
Yes, that's actually it's a very important topic that you just brought to the table, and it's becoming more and more relevant, not because now it's relevant and before it wasn't, but because more and more scandals are being exposed. Like I wasn't aware of this one, but I'm aware of other ones. Like there was also insurers that they were pricing people differently based on their name. If you have an Arab origin name, then the premium for you was higher. This was also in the news. So yes, it's sad that it's actually happening. How can we help? I mean, there are tools that help us understand how the models are producing their decisions. Like to begin with, there are models that are intrinsically explainable. They are normally the more boring ones from the data science perspective because they are actually statistical models, like, linear regression, logistic regression. When you enter into data science, you want to do cooler stuff. So, you always, at least for me as a beginner, like I wanted to do cool stuff. No, linear regression, I mean, it's so boring. But there are tools to interpret models that are less explainable, if you want. So, yeah, that's the key thing. Like the key answer to that question is that we need to understand how the models reach to their conclusion. And then if there is a feature that shouldn't be there, or it's a conclusion that is kind of funny and ethical, you just redo your model. I mean, remove that feature and start over. So that's one thing. And then the other thing is your model usually is going to serve a huge population, and then you need to understand how the model is affecting different parts of the population. And that we actually did in the finance company. Like you say, okay, these people that are the wealthier, how the model is doing, these people that are not so wealthy, how the model is doing, what are the consequences? And then you try to mitigate as much as possible, the potential damage that you can use. I mean, and there are examples all over. The one that you mentioned about firing people, there are examples about recruiting people. I mean, people are not being recruited because of psychological test answers, which is beyond ridiculous. People are put in jail longer because of models that relate normally with ethnicity and neighborhood. I mean, it has to end.
And it's not to go too far off into this sort of digression, but it's very depressing when you think about the people that are making these decisions and have these, like, if you understand things even a little bit from the kind of technical perspective, and then you understand this is sort of incredibly clunky, abusive and naive way that they get used by people who actually have the power to make decisions and stuff like that. It's very sad. And I guess all we can do is hopefully write more books and get people to take more courses to learn more about how these things actually work and what's actually going on under the hood. You mentioned actually one interesting thing about like there's about sort of interpretability and things like that. And so I think that's maybe a good opportunity to just take a few minutes to talk about three of the feature selection algorithms or methods that you talk about in the book. The one is the filter method, the wrapper method, and the embedded methods. And you describe in your book that the filter method selects features based on the intrinsic characteristics of the data, ignoring their interaction with the machine learning model. So is that the kind of thing where it's just sort of like kind of my simple thing before, where it's like, oh, I know I've got some various things like time of day and et cetera, and I'm actually not doing anything sort of fancy to kind of visualize what's going on or tell a story about what's going on?
Some of the filter methods are like really old school statistical tests, like ANOVA, correlation, and chi-square. So you can say that they are not fancy because they are like super old and they are not like more modern techniques if you want. So I guess, yes, I mean, it's statistical tests. They offer a first screening. The advantage of filter methods is like they are super fast, computationally speaking, and they offer like a first screening to say, okay, yes, this feature differs across different patterns of the targets. Mm-hmm. But I mean, they have some limitations, like correlation, measures monotonicity or linear relationship, depending on the correlation test that you're using. ANOVA is also a linear test. So those tests are not super good for tree-based algorithms that pick up nonlinear relationships, for example. There are others like the mutual information, but it's based on probabilities. They also have limitations. I would say that almost every feature selection method has its advantages and limitations. These are the ones for filter methods. So they're good for the first screening. you also analyze features individually, which is good because other methods basically cannot tackle correlation between features very well. So they will mask the feature importance if two features are correlated between themselves and then with the target. Whereas these methods, because they look at the feature individually, would say, okay, the two are really important. So yeah, pros and cons, I would say.
And the wrapper methods involve the use of predictive models. So how does that work in practice?
The wrapper methods, they are cool in theory. I'm yet to find someone that actually uses them because they are computationally so expensive. So the original idea of wrapper methods is that, okay, we have a data set. We're going to try all possible feature combinations, like one feature by itself, all possible combinations of two features, all possible combinations of three features, all possible combinations of four features, and so on. And then basically for each of these combinations, you build a machine learning model, you analyze the performance, you rank the models, and then you select the model with the features that ranked the highest. So this is the idea. So in theory, this should allow you to get the best performing model. In practice, it is so computationally expensive that it's impossible to carry out in any system. So some alternatives were invented, like instead of trying all possible feature combinations, you start with one feature, then you start one and build a model, and then you add a third one, and then you build the model. So you build less models, but you still build a lot of models. So that's the alternative. That ones are a little bit more practicable, if you want. So yes.
Yeah, that's really interesting. It actually leads me to ask a sort of question, like when we're talking about like computation and stuff like that, like how big are the data sets that we're sort of talking about here? Can they be like, 1,000 terabytes or something like that? Whatever that term is.
Yeah, so I guess it depends on the industry. Like
right.
For finance and insurance, we could talk about, I don't know, like maybe 300 customers to 1 million customers, and then variables in the thousands or in the hundreds, depending the model. Like for credit data, you could get thousands of variables. For fraud, a little bit less, maybe hundreds of variables. So for these industries, I wouldn't say that the data sources are huge. But if you are like these delivery companies or the mobility companies that they basically gather data constantly, then these data sets are huge because basically you have data every second, or like streaming companies like the ones that provide music. So I think it basically varies a lot with the industry that you're working with.
And so going back to your story here, eventually, and it's sort of related to your book, and this is sort of where we sort of move into the last part of the interview where we talk about your work as an author and content creator and things like that. So you were in academia, and then you were working for business, and then you made the transition into sort of self-employment because you love teaching and you're good at it, and you like writing books and making courses and things like that. Was that something that you always knew you liked, or was it something that you just kind of discovered partly through your own journey, learning data science and things like that with online courses?
When I was doing my PhD in Argentina a long time ago, I was also teaching at university. It's kind of like a requirement or a nice to have, teaching and doing research. And so for 5 years, I think I taught at university, and I really loved it. And it was so much fun, and students make interesting questions. So yes, I really loved it. Then I moved to London and Germany. So like for 6 to 8 years, I kind of forgot about teaching. And then when I started creating the courses, it's kind of like I found out again how much I liked it. And I also find it super rewarding because people do tell that they come to me on LinkedIn and they say, oh, I really like your courses. It helped me answer the interview questions. Like, what a job, thanks to your course. And I was like, wow, I'm making an impact. For the first time, I felt that what I was doing was actually useful. So that was a very strong motivation. On one hand, I like teaching. On the other hand, people are sharing with me that they find the courses helpful. And I also like learning, and teaching is one of the best ways to learn because you need to learn a lot before you can actually digest something into a way that it's easy to understand. So yeah, that was the motivation.
Definitely. And so before you sort of went independent, had you already had some success with like, books and courses and things like that that sort of encouraged you to make that step?
I created the first course almost like a hobby or like a side project without really knowing what was going to happen. I didn't imagine that it was going to be this successful, so to say. But it was very well taken, and students, they're very helpful. They provide feedback like, oh, we need more of this and less of that. So I was kind of tuning the course and becoming a better instructor all along. So I created a second course and I put it out there. And then after the third one, I saw that, there was room to basically do this full time. I was a little bit scary because, I was never self-employed before. And this usual risk, like, am I going to be able to get a job later on? But then I said, whatever, I really like this. So I went full on, and here I am.
Yeah, no, that's just fantastic. It's just so great. And actually, one sort of self-publishing specific kind of question I guess I have is that, and sorry, I don't know the answer to this as well as I should, but have you been publishing your books on Leanpub in progress, like chapter by chapter, or were they? I feel like actually at least the first one was kind of more or less complete when you published it.
Yes, I was complete. Mostly because it helps my motivation. Like if I need to finish the book, then I sit and finish the book. If I have one chapter and then people are buying it already, then, it's for my own sake as well as for the sake of those that are going to read the book, I better sit and complete it.
Makes sense. And makes total sense. And actually the last question that I always like to ask on the podcast, if the guest is a Leanpub author, is if there was one magical feature we could build for you, anything you could ask us to do, or if there was one thing that had you shaking your fist at Leanpub that you wished we could fix for you, is there anything you can think of that you would ask us to do?
Wow, good one. I wasn't prepared for this. I think a reader's review that is automatically collected and displayed on the website would be amazing.
Yeah, to have reviews. It's one of those sort of like, reviews are really interesting. They're great when they work, but they can be a total minefield as well. We do have a testimonials feature, so you can actually like publish testimonials yourself if people sort of give you a little blurb and this and that. You can put it on your book landing page and things like that. But yes, reader reviews are something we've had requests for in the past. We will do something around it someday. The whole sort of social aspect of things is this big kind of like unexplored part of the map for Leanpub, and there's a lot of room for us to improve there, and particularly reader reviews is something that would be great. And because we do in progress publishing as well, not necessarily for all books, but for some, reviews can even be a little bit trickier. People might be like, oh, how do you review a book that's 3 chapters in, things like that. It can be a little tricky, but that's definitely something we're going to work on. But anyway, thank you very much for taking some time out of what I'm sure is a beautiful morning in Berlin to talk to me and to talk to our audience. And thank you very much for using Leanpub as the platform for your books.
Yeah, thank you for creating such an amazing platform.
Thanks.